Hello, can you hear me?
Yes, I can hear you.
And can you see the screen?
Yes, sir.
Okay, good, good. I think they fixed the problem. All right. So how are you guys doing? I hope you are doing good. Um, Today we'll be rounding up the chapter on probability theory. We have finished the Bayes theorem last Tuesday. Now let's look at the fundamental accounting rule. Now, that does not mean that we are done with the probability. We are still going to meet them again. Um, in fact, almost I would say in two different topics again, the binomial distribution and the normal distribution. We're going to encounter probability in different forms. But today, let us run the chapter with this. We call it fundamental accounting rules. Um, okay. Now, the fundamental accounting rules, as you can see from the screen, give me 1 minute. Let me make it properly. Good. As you can see from the screen, it says in a sequence of n events in which the first one has k1 possibilities, the second event has k2 possibilities, and the third event have k3 possibilities, and so on, then the total number of possibilities will be to multiply all the k's. That is k1 times k2 times k3 up to the last k that you have. Okay? And let us apply this here. It says a coin is tossed and a dice. Let me call it dice, just dice, feel the dice. Although dice is still the correct name. So a coin is tossed and a dice is rolled. Find the number of outcomes for the sequence of this event. When a coin is tossed and a dice is rolled, it says find the number of outcomes for this sequence of events. For a coin have two sides. So K1 is 2, and the dice have 6 sides. Is 6. So that number of outcomes now becomes K1 times K2. Okay? K1 times K2. So which will be, I'm going to adjust this a little bit. K2, and this one is K1. So K1 is 2, and K2 is 6. And that will give us 12 possibilities, 12 outcomes, 12 possible outcomes. That is the basic thing this theory, this fundamental accounting rule is saying. You multiply the number of possibilities for each event, and then you get the total number of possibilities. Now, this question can be asked in a different form. Look at this. Let me move it down so we can have enough room. It says here that let me make this make it make it 18 then. Good, that's better. It says that a paint manufacturer wishes to make several different kind of paints. The categories are as follows: color, see red, blue, white, black, green, brown, yellow. Type can be latex or oil. Texture can be flat, semi-gloss, high class. Then outdoor or indoors, just use of that paint can be outdoors or indoor. You see how many different kind of paints can be made if a person can select one color, one type, uh, one texture, and then one use. So let us look at this. Let us, I will say, summarize this with using the cares, okay? So that we have care one, will be color. How many colors we have? 1, 2, 3, 4, 5, 6, 7. 7 colors. So care one is 7. Care two is a type. Latex or oil, there are 2 of them. Care three is the texture. We have flat, semi-glass, high glass, which is 3. Care four is use. Can be used outdoor or indoor. So that number of different kind of paint that we can make will now become care one times care two times care three times care four. That means care one, okay, care one times care two times care three times care four, care one times care two times care three times care four. Okay. Now I'm going to make some adjustment to this, which will be equal to, okay. Let me adjust this so it looks like it should look. Okay. Okay. Apply the 4 of them. Oh, so I'm gonna adjust this. Gonna be K3. Okay, this is K2. This is K1. And K1 is 7. So you're gonna be 7 times 2 times 3 times 2. That'll give you the how many the number of different kind of paint that can be made with this. Okay, the different kind of paint that can be made with this. So I'm gonna write this down, and we can now get them from the calculator. 7 times 2 times 3 times 2, so that we have 7 times 2 times 3 times 2, which is 84. So we can make 84 different kind of paints given this arrangement. 84 different kinds of paints given this arrangement. Any question on this, class? Any question? Any query?
No.
Excellent, excellent. Now, let me try one that is a little bit challenging, which you might see in maybe in one of the homeworks. I might put one of this type, who knows? Anyway, it says here, the digits are 0, 1, 2, 3. Let me make this 18 so that we can see very well. Yes, let me make it 18. Yep, that's better. The digits 0, 1, 2, 3, 4 are to be used in a 4-digit ID card. How many different cards are possible if A, repetitions are permitted, B, repetitions are not permitted, C, repetitions are permitted, but the first digit cannot be 0 or 1. Let's start with the first one. First of all, it is a 4-digit ID card. So there are going to be 4 slots. Okay. Can I be the first slot? The second slot? Each slot with the numbers. Third slot. Fourth slot. So you got a 4-digit ID card. And you have 5 numbers to choose from. Now, part A says repetitions are permitted. That means, what does that mean? Let me take this, okay? This, okay. We have that repetitions are permitted. That means you can use any of this number in any slot as many times as you want. Okay. Which means to this. We look at this, you see, let's say this, we have 5 numbers. Let me write the 5 numbers down here. 0, 1, 2, 3, and 4. Okay. So you can use these numbers. Let us start with let's say this 0. You can use this number 0 as many times as you want here, as many times as you want in any slot. You can use 1 here as many times as you want for different combinations of numbers. And so I'm same thing with 3 and 4. So because of that, you have 5 numbers. That means you can generate how many ID card with this, since you can have each number in different slots as many times as you want. Even you can even start put 1 here, put other numbers here. Then later on, you put next card, you can put 1 at the beginning. And in any slot you want. And you have 5 numbers. So number of cards for this particular scenario will be cards will be, you have 5 numbers to choose from, but 4-digit ID card. So you're gonna be, since you're gonna use each number in each slot, however you want it, whenever you want it, in what slot, in whichever slot you want it. So you have 5 times 5 times 5 times 5. Why 5? Because we have 5 numbers to choose from. Why stop on the 4th multiplication? Because you have the card will have only 4 digits. So taking you to the calculator, we have 5 times 5 times 5 times 5. We have 625 cards. 625 cards. Okay. 625 cards can be met. Okay. As B says, repetitions are not permitted. In this case, unlike the first one where you can use any of this number, any digit on any of the slot, however you want it. In this case, if you use 0 in this slot, you can never use 0 again in that slot. But you can use it in the other slot. Any slot that you use 0 on, you can't use it in that slot again. Same thing with 1. If you use 1 in this slot, you cannot use 1 in this slot again. But you can use it in any of the 3. And if you use it in any of the 3, that means you cannot use it in that particular slot, even though you can use it in the next slot. The same thing with 3 and 4. So you are restricted by the number of times you use each slot, each number in any of the slots. So that means it keeps decreasing. So in that case, number of cards possible, see, it keeps decreasing. That means 5 times 4 times 3 times 2. And that will give you how many cards possible. We got okay, 5 times 4 times 3 times 2. Give it 120 cards are possible in this case. 120 cards. Okay. 120 cards. Okay. Part C says, now, see here, repetitions are permitted, meaning that you can use the card, any of the numbers in any of each slot as many times as you want. But the first 2 cannot be, the first 2 digits, that means the first slot and second slot. The digit in the first slot and the second slot cannot be 0 or 1. That means out of this, let me copy it, maybe because this one might need to explain more on that. Let me just put it right here. So out of this 4 slots here, okay, and you have 5 numbers to choose from. But for the first 2 digits, the first slot cannot be 0 or 1. So you have to remove. So that means you have only 3 numbers available for the first and second slot. But the rest of them can be, just these first 2 can be, sorry, it says here, but the the first digit cannot be 0 or 1. Okay, that is only the first digit. So these first digits that have first slot, you have only 3 numbers to use there, anyhow you want. But the rest of them, second slot, third slot, you can use odd numbers. In that case, we have that um we have that number of cards equal. Now for the first slot, you cannot use 0 and 1. So that means you have 3 numbers available for that first slot. So in that case, that's going to be 3. But the rest of the slots, you can use any of the numbers you want. So 3 times 5 times 5 times 5. So we can get it from here, from the calculator. 3 times 5 times 5 times 5. 375 cards can be made. 375 cards. Okay. 375 cards. Any question on this? Any query?
No, no questions.
All right. So now, in that case, we can now round up with this concept. It is called permutation and combination. Permutation and combination. Okay. Now, permutation is the arrangement of n objects in a specific order. Okay. While combination is the arrangement in with no specific order. That's the difference. In permutation, there's a specific order. In combination, there's not. For example, for permutation, let's say that you choose the president before the vice president. The party should select the president first. Then the president will select the whoever he want to be or she want to be the vice president. That's to give you an example of permutation. But combination, let's say that it want to say have a you are the owner of a bike store and you want to promote the bike. You might choose 4 bikes out of the whole bikes and in any order you want, and then promote them. So now this is the formula for them. But for this class, we'll be using the calculator to do them. Before we start working on those, I want to show you what a concept that is basic to these two concepts, which is called factorial notation. In the English language or in your writing class, this symbol here represents exclamation mark, but in statistics, in maths, it represents factorial. So if I say 5 factorial, for example, it means 5 times 4 times 3 times 2 times 1. Okay. So that means 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. And something like 8 factorial will now become 8 times 7 times 6 times 4, times 5 times 4 times 3 times 2 times 1. So you can see that for each number, it just keep multiplying down. Okay. So I'm gonna go and get it from the calculator for 8 factorial. So we got 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Give us 40,320. 40,320. Okay. So this is the a concept that we used to build this formula for combination and permutation. You can see that this one is n factorial over n minus x factorial. And this one is n factorial over x factorial, n minus x factorial. So this is NPS means n permutation x. And NCS means n combination x. So like I said, they are built based on this formula and on this concept, factorial. But we'll be using, since you're not, this is just here, for this class, we'll be using a calculator to calculate these two concepts. Look at the first one, which is permutation. Okay, let me make it 18. It says evaluate this. Evaluate. First one says evaluate 12 permutation 3. Part A, solution for part A. It says 12 permutation 3. Okay, that means I'm gonna write it here. 12 permutation 3 equal. Let's see what the answer will be using our calculator. Okay. So you go to the calculator, but for this case, if you say 12 permutation 3, that means your n equals 12 and x equals 3. So 12 permutation 3 will now become, let's say, you go to your calculator. Depending on this one uses, I'm going to show you with this one, but if you have a scientific calculator, you might check your manual, see the methods that calculator uses to find permutation. For this one, just click on the function key. Now you can see what you have, MPR. Click on that. Then our question was to find 12 permutation 3. So you got to put 12 comma and 3 here. And I'll give you the answer right away. 12 comma 3. And you close the parenthesis. Gives you 1320. That's the answer. 1320. 1320. So it's gonna be 1320. That's 1,320. That's it. Like part C. So if I ask you something like, let's say I ask you to find 6 permutation 4. 6 permutation 4. Okay. Can just make this adjustment. In this case, our n equals 6 and our x equals 4. So in this case, 6 permutation 4 will now become, if you go to the calculator, and then again, click on the function, erase this, click on MPR, 6, comma, 4. That'll give you an answer right away. 360. 360. Okay. So you get 360. So that's how it's done. Otherwise, you can use the formula to find it. You can explore that. I give that to you. Now let's look at the application of this. Suppose you have this problem here. Okay. Suppose you have them, and then we have a TV news director which used to use 3 news stories on an evening show. One story will be the local lead story, one will be the second story, and the last will be the closing story. If the director has a total of 8 stories to choose from, how many possible ways can the program be set up? Okay, so now this is a permutation program, because you see that there's a specific order. One story will be the local lead story, one will be the second story, and the last will be the closing story. See, specific this order, in this order. Excuse me. So that the director has a total of 8 stories to choose from. So our n is 8. And he's going to choose 3 stories for the 8. So our x is 3. So it says, how many possible ways can the program be set up? Okay. And say number of ways equals 8 permutation 3. Okay, that's what it's gonna be. 8 permutation 3. Oh, excuse me. 8 permutation 3. Okay. Oops, my bad. 8 permutation 3. Okay. That means we have go to the calculator, 8 permutation 3. So that we have this click on the function, click on MPR, type 8, comma 3. 336 ways, 336 ways. 336. Yes. Yeah. Any question on this? Okay, excellent. Now let's look at combination. Like I said, combination is the same, yeah, almost the same approach, but this time around you're using NCX, not NPX. For example, if you're asked to do this, evaluate. To evaluate. Let me put solution here. Evaluate any of this. I'm going to make it 18. Part A, solution. 7 combination 4. Have 7 combination 4. Can I make this 18? We're gonna make this format this, make it like the way it should be. So in that case, like I said, for the calculator, instead of using P, use C. That's the thing here. So we go to the calculator. Now, before we do that, we know that our N here equals 7, and our X equals 4. I'm gonna adjust this. Okay. So now let's go to the calculator and put them in. So when we get there, instead of using MP X, we're gonna be using click on the function first, use NCR. So that means we have our problem says to find or evaluate 7 combination 4. That means 7, 4. So 7, 4 is 35. 35 ways. 35 ways. See? So that's how it works. Now, we can now look at the application for this. It says a bicycle shop owner has 12 mountain bicycles in the showroom. The owner wishes to select 5 of them to display at a bicycle show. How many different ways can the group of 5 be selected? So you have 12 mountain bikes, so N is 12. And you need to select 5 of them. That means in any order. Doesn't matter any order. So that means it's a combination problem. 5 of them. So how many different ways can this be done? Number of ways this can be done is 12, okay, equals 12 combination 5. So this is 12 combination 5. Okay. That means go to your calculator. 12 combination 5. Okay. Click on the function NCR 12, 5. 792 ways. 792 ways. 792 ways. Excuse me. Any question on this one?
No.
Okay, good. Excellent. Let's try the one that is a little bit challenging. And it says here, in a club, there are 7 women, 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? So now you have 2 situations here, men and women. So now in men, we have 5 men. Okay, I have 5 men. So N is 5 for men, and women, we have 7 women. N is 7 for women. And for, see, a committee of 3 women and 2 men is to be chosen. So women, S is 3, and men, S is 2. Okay. So how many ways, how many different possibilities are there? Okay, you can say number of possibilities equals, for men, you have 5 combination 2 times, for female, we have 7 combination 3. Okay, to get your answer. Okay, onboard it. Okay, and then make these adjustments. All right. Once you finish the adjustment, we can just get our answer right away. Okay. So for men, for 5 combination 2, we can go to the calculator, 5 comma 2. Okay. 5 comma 2 is 10. So we go over there and write 10. 10, men, times 7 combination 3. Okay, we go to a calculator again. Make it 7 comma 3. Yes, that's 5. Okay, that's 5. So we go over there and put that 5 right there. Blocking this, close this. That's 5. Make sure I have it correctly over there. Yep, that's 5. I have it over there. That's 5. That'll give us 350 possibilities. Any question on this? Any query?
No.
So now with this, we rounded probability. So we are finished with probability now. Now I'm going to let you go. See you guys Tuesday, okay?
I have a question. Are you taking attendance?
Yes, I am. As you are logging in.
Yeah, I joined really late because I didn't see the link in the
What's
new
your
link.
name?
It's Sarah Durant.
I marked you already.
All right, thank you.
You're welcome.
Have a good day,
I
Professor.
got a question too.
Have a good day.
Have a good day.
Yes, yeah, sure. You too. You too. Ask a question, sir.
I want to ask you, are you still gonna post like a video of a brief example of how the class? Because in the classwork assignments due this Friday.
Yes, the video is here already.
Oh, it is. You already attached
You
it.
type your name. Oh, you want me to put it in that place, right?
Oh yeah, yeah. If it's possible, like to attach it to show like a brief example, like
Okay,
how you want to.
okay. Let me do it now. Yeah, I'm gonna do it now.
All right, thank you.
Oh, you're welcome. You guys have a nice day now.
You too.
And did you get me for attendance too?
What's your name, ma'am?
Davin Williams.
Yes, to me. Hold on. Yep, I got you here.
Okay, thank you. Have a good day.
You too. All right.